Hello friends, in this video we are going to see about statistics and data visualization. So this is the third session in the series, and so statistics, as we have seen in the first session, like it comes from the German word statistic, and it means a description of a state or a country. It is a discipline that concerns the collection, organization, analysis, interpretation and presentation of data. In applying statistics to a scientific, industrial, or social problem, it is conventional to begin with a statistical population or a statistical model to be studied. Next, these are some of the types of graphs which we will come across in probability and statistics. There are many more charts and many more graphs. The definition of graph and chart is being discussed in session 1. So these are the types of graphs. So here we will discuss about how each plot is being done. So stem and leaf plot. So stem and leaf plot here, the numbers will be segregated. Like if it is a 2-digit number, the number will be segregated into tens digit and a units place. So tens digit will come in the left, and the unit place will come in the right. So if you see, for example, in the right side of train departures figure, the 510, there is a 5 departure. So 510, 517, 529, 539, 554. So 5 is going to be there in left side. Similarly 6. So this kind of plot is known as stem and leaf plot. And there are how it helps means in many figures, if we search in internet, we will be able to see that this 5, 6, 7, 8, 9, these forms the stem, and these are like these will be the 10, the numbers, the other numbers will be represented as leaves. So that's why the name is stem and leaf plot. And next we will go to box plot. Box plot is also known as box and whisker plot. It is a graphical representation of the distribution of a data set. It provides a summary of key statistical measures and helps in identifying the central tendency, spread, and potential outliers in the data. So if you see in the right side figure, we are seeing some in the first figure we are seeing a box is there, and there are 2 lines which are drawn from the box towards the end, and there is a final line, small line, which is drawn. And in the third plot, if you see in the first plot, there are no dot, there is one dot which is lying outside extremely. And in the second box, if you see there is no outlier is there. So how this box is constructed? So how this box is constructed was discussed previously in session 1, but here again I will just recollect it. So in here there will be 3 quartiles. Quartile 2 is nothing but the median. Median is nothing but the after arranging the numbers in ascending order, the middlemost number is the median. So that number will be the quartile. If there are number of numbers is going to be even numbers, then the average of the 2 numbers is going to be the median. So that will be the quartile 2. And quartile 1 and quartile 3 will be the median of from the quartile 2 to first number. So that median is going to be representing the quartile 1, and from the median number quartile 2 to the end, the middle number, between these 2 numbers, the middle number, that will be the quartile 3. So it could be said like quartile 1 is 25% of the data, and quartile 3 is the 75% of the data. So how we found out the quartile 2? The same way we will find out the quartile 1 and quartile 3. So then we will construct this box. So the middle line represents the median. So next we will define what is the range which we expect. So if we say like 1.5 times, for example, if we say 1.5 times the quartile 1, so 1.5 times the quartile 3. From there we draw the line towards the end, and we define the end. So that end is line like a pump. The figure looks like a pump that towards the end. So that is the end of that thing. Whatever data comes outside that plot is marked as a dot. So those dots are nothing but the outliers. So in the third plot, if you see, the dots are there, above the third figure. So this figure also comes in financial analysis. Also this figure comes when we in the financial analysis. Also this figure comes. This is known as the morning star, the emoji. In those names, this kind of box and whisker plot comes. And right side, if you see, there is a normal distribution, and the normal distribution, the median is there because it is a normal distribution and it is a bell shaped curve. The mean is equal to median is equal to mode, so that is equal to the quartile 2, and quartile 1 and quartile 3 are found out by similarly from the median towards the 3 sigma, towards the end of the towards the first, after arranging the numbers. So towards the beginning, if we go and find out the median between quartile 2 and quartile 1, we get the between the first number and the quartile 2. If we find out the median, then that is going to be the quartile 1. Between the median and the last number, if we go in to find out the median, then it is going to be the quartile 3. So after drawing the plot, we are just writing down 1.5 times into interquartile range. So this is known as the IQR. Between what is there between Q1 and Q3, it is known as IQR. And if we tell like minus 1.5 times the IQR, if we go to the left, we tell like minus 1.5 times the IQR. We define that value 1.5. What value we need? 1.5 is going to represent 3 sigma when it is a bell shaped curve, and plus 1.5 is also represent the plus 3 sigma in the right side. So we define these values, and then we draw the box and the line, and then finally we see that here there are no outliers. That's why there is no dots which are kept outside this range and outside this box and whisker plot. And next type of graph is bar graph. So used to represent categorical data where each category is represented by a bar. So here in this plot, if you see, this is for example like the system language is there, another one is machine language is there. These are two categories of data, and each category, so categorical data, so this length of the bar corresponds to the frequency or the value of the category. So here it represents the value of the one or the frequency of the one. The three plots refers to the value or the frequencies, 3 bars. And then the histogram is similar to a bar graph, but for representing the distribution of continuous data. Here there are no spaces between them. This is not here it is a continuous data. It is like a bell shaped curve. So this is for representing a continuous continuous data. Next, other type of charts, not directly involved in probability but involved in statistics. A Pareto chart. Pareto principle works like 20%. 20% is 20% of the people. It works on a 20%, 80-20 principle. So 20% of the people are more wealthy than the 80% of the people in the world. So if on that basis the Pareto principle works. So the Pareto, in short, to put it in briefly, we can tell like a small number of factors contribute to large number of different, like cumulative effect of different factors. So it is like small number of factors contribute to a large percentage of the overall impact. So in statistics, Pareto charts are often used in quality control and process improvement to identify and prioritize the most significant factors or issues affecting a system. So construction, how to construct this graph is mentioned here. And Pareto chart, how the Pareto chart looks. In the right side it is given, and it is considered like one of the 7 basic tools of quality to access the most frequently occurring defects by category. So Pareto chart of investment casting defects, titanium investment casting defects. So that is there. So how the Pareto chart is constructed? The chart combines a bar graph and a line graph. Bars represent individual factors sorted in descending order of their impact. So in the red is the most highest impact causing factor, and then descending order each bar is drawn. the line graph shows the cumulative percentage of the total effect. So here it is one like after cumulative means addition. After red, next if on top of red, if yellow is added, the dot represents that yellow value. So like that the line goes. The line graph shows the cumulative percentage of the total impact. So might be able to identify the most common defects in a production process, helping focus process improvement efforts on the critical issues. Bubble chart. So this is used in statistics. Bubble chart is used to visualize the three-dimensional data on a two-dimensional plane. So three-dimensional data on a two-dimensional plane. So here there are circular packing chart on right side. If you see the figure, circular packing chart is there, sometimes called a bubble chart, showing the proportions of people who create programming language. So here the orange might be the systems engineer, and the blue will be another developer. So each person will be there, and each data point is represented with the size of the bubble indicating the third dimension. So what kind of impact they are creating, what data correspond to that value. So that thing is used in the bubble chart. Like each data point is represented by a circular bubble with the size of the bubble indicating the third dimension. So greater the circle, greater the dimension, greater the impact, it could be said. In statistics, bubble charts can be used to display relationships between three variables, providing insights into patterns, trends, and correlations in the data. And construction, the x and y axis represent two variables. The size of each bubble represents a third variable. Additional dimensions can be represented using color. Example, in finance, a bubble chart might be used to visualize the relationship between the market capitalization of companies x-axis, their stock price y-axis, and their revenue. Revenue will be the bubble size. So while Pareto charts and bubble charts may not be directly associated with probability calculations, they play important roles in statistical analysis and data visualization. These tools help researchers and analysts understand patterns in data, identify influential factors, and communicate findings effectively. They are valuable in various fields, including quality control, business analytics, finance, and more. There are many charts such as pie charts, heat map, scatter plot, Gantt chart, 3D pie chart, 3D bar chart, and many more are there. So Gantt chart is used in project management. These could be referred, and these are not covered here because this topic is mainly focused on probability and statistics with reference to its application in science and industry. The industry means it refers to how quality control. It could be covered definitely, and future, if possible, we'll try to cover each the type of chart, specialized chart, as a specialized topic after getting some information. Okay, and that's it. Thanks a lot.